Alright, so we just got done with volume of cylinders and prisms. Now we're going to talk about pyramids and cones. And the process is very similar, there with one exception. So with a cylinder and a cone, or excuse me, with a pyramid and a cone, it's just like before. You take the area of the base, you multiply by the height, but you also have to multiply by a third. So if you have a cone and a cylinder, for example, that have the same height and the same radius, the volume of the cone is a third as much as the volume of the cylinder. Alright, so let's go ahead and jump into this. Okay, now one thing to pay attention to is now when we were doing surface area of cones and pyramids, we had to use the lateral height, which was basically the height along the surface of the triangle, because we're focusing on surface area. Okay, now that we're doing volume, we want the actual height. So from the center of the base all the way up to the tip of the triangle. From the center of the base to the tip of the triangle. So if you need to go back to that video from last week, or you never watched it and now you think it would be a good time to do it, go ahead and go back to last week's stuff and look at that video that I posted about excuse me. Look at that video that I posted looking at the differences between height versus lateral height. Okay, surface area, we want to use the lateral height. Volume, we want to use the actual height. Okay, so here you can see that this is the center of the base, and it's going up to the tip of the triangle, or to the tip of the pyramid. So that is the height that we want. So you have to start by taking the area of the base. The base is this shape right here, which is a triangle, specifically a right triangle. So we're going to take the area of that triangle, which is half of the base of the triangle, which is 4, and the height of the triangle, which is 6. All right, so that part right there is the area of my base. Next, I need to multiply it by the height of the pyramid, which is from the middle, of the base up to the tip of the pyramid. So that's the 9. And then because it's a pyramid instead of a prism, we need to take a third of that. So let's go ahead and start in here. 4 times 6 is 24. Half of 24 is 12. Half of 12, or, sorry, that's supposed to be a third, because that's that. A third of 12 is 4. And then we get 4 times 9, which is 36. And our units is meter. We're talking volume, so it's going to be meters cubed. Oops. And you can see exactly what I got over there. Alright, now we're looking at the cone. We're trying to find the volume. So I need 1/3, because it's a cone. The base is a circle, so area of a base, area of a circle is pi times the radius squared. And then from the center of the circle up to the tip is 16. Now there's one small problem. I'm supposed to find the volume. Okay, so this isn't one of the problems where they give you the volume and you solve for the radius. They want me to find the volume. I was not told the volume. But as you can see, we need the radius to find the volume, but that was a piece of information I was not given. So I need to try and come up with a way that I can find the radius. And so looking at the picture, what we have here is we have this height. We also have the angle formed. And that's right there. So we're going to have to go back and review some of our right triangle stuff. So Pythagorean theorem was one option. We used that in the last section. A squared plus b squared equals c squared. That's a possibility. Okay. Got a right triangle, so Pythagorean theorem is a possibility of finding missing side. But Pythagorean theorem, to use Pythagorean theorem, we have to know two of the sides, and then we use it to find the third. I only know one side. I can't use Pythagorean theorem if I only know one side. So Pythagorean theorem won't help me find the third side, or to find the radius in this case. But I have a angle. I have an angle. So I need to try and find the missing side using an angle in one of the sides. And in that case, we have to use one of our trig functions, sine, cosine, and tangent. All right, so we need to use sine, cosine, or tangent to find that missing side. Okay, so here's the angle we have. So remember, when we're doing this, we start by marking that angle and then going ahead and figuring out opposite, adjacent, and hypotenuse. So here's the angle. This side across from that angle is going to be your opposite side. Okay, the side across from the right angle is always your hypotenuse. And then if this is the angle I'm looking at, this side is next to or adjacent to. So looking at this information, I'm given the opposite side and I'm trying to find the adjacent side. I'm given the opposite, trying to find the adjacent. So thinking back to our trig functions, which trig function utilizes opposite and adjacent? So let's go back to the mnemonic that we had to help us remember. SOHCAHTOA. So, ka, toa. SOHCAHTOA. All right, so we want the one that uses the opposite side, because that's what I'm given, and the adjacent side, because that's what I'm looking for. So I want opposite side and adjacent side. Here, the S stands for sine, opposite, hypotenuse. So sine of an angle is opposite over hypotenuse. Cosine, the C stands for cosine, cosine of an angle is A over H, so adjacent over hypotenuse. And TOA, tangent, the T stands for tangent, O over A, so opposite side over adjacent side. We want to pick the trig function sine, cosine, or tangent that uses the opposite side and the adjacent side. Opposite and adjacent right here, so we want TOA. So tangent. So to find the radius, we're going to have to set it up as tangent. It's always tangent of the angle, in this case 65 degrees. Then we set it equal to, pay attention to the order, it's TOA, O, and then A. So your opposite side is 16. Your adjacent side is your radius. That's what we don't know. So it's always got to be the O on top and the A on bottom, regardless of which one you know and which one you don't know. Okay, it's always, sorry, I just dropped my pen. It's always the O on top and the A on bottom for TOA, because it's O then A. All right, so here, what we have to do is we have to try and get, so one thing that we said we could do is we could just put this over 1, because that makes it a proportion, and we learned how to do proportions already, so we cross multiply. 1 times 16 is just 16, and tangent of 65 times r, I can't multiply by r because I don't know it, so that's r times tangent of 65. I think I said 16, tangent 16 before, sorry. Tangent of 65. So now I've got r times that tangent, so I need to divide by tangent of 65. Divide by tangent of 65. And make sure that, yeah, you can follow along with the video, but go ahead and type that into your calculator. Don't just wait for me to give you the answer, just to make sure that we remember how to type it into our calculator. And if not, let me know, and I'll try and review that with you. Send me a message via reminder, whatever the case may be. Make sure we remember how to type that into our calculator. You should end up, if you take 16 divided by tangent of 65, you should end up with your radius equaling 7.46. Make sure that it's 16 divided by tangent of 65, not the other way around. Okay, 16 is on top, divided by tangent of 65. All right, so you get 7.46 for your radius. Okay, so I'm going to go ahead and click what I have work here. Okay, so just catching up on my clicking. So I'm going to erase this over here now because that's what I have. Done over here. So I took tangent of 65 equals 16 over r, and then I did the cross multiply and got, and then divided, and we got r as that. So we said to find the volume of this, I need to take 1/3 times pi times the radius squared times the height. I knew the height was 16, but I had to find the radius. Now I know the radius. So that can be stuck into there. I'm going to have 1/3 times pi times 7.46 squared times 16. And this is what you get, 932.45. Now, if you go ahead and you take 7.46 squared times 16, and then take 1/3 of that, you would get 296.81. So that's taking that, and that. So everything but the pi. So you could also write your answer like that, 296.81 pi feet squared. Feet cubed, excuse me. But again, always remember your units.